This is a review of assignment 5. So our first task was flavor operations to fill in some code for a static class. And here we see that project. And let's take a look at flavor. All right, so we've added an all flavors field. Of course, that's a private field. This will store the list of all the possible flavors. We have a static constructor that populates that using a for each loop. So for each string in the flavor name, we add that to the flavor enumeral. Now, one thing to note here is I did choose to loop through these as strings. I wanted to get a chance to use my toFlavor method. However, that's not actually necessary. I could have looped through these as flavors. In order to do that, instead of looping through the names, I loop through the values. And then this step is not necessary. And I would, of course, want to probably change this. Here's the converter that converts a string to a flavor. I think we've seen this code before. And here is my property, all flavors, that returns all the possible flavors. Now, I would like to point out that this is a shallow copy. So let's see how that might affect our code. I'm going to go to Program and Main, and I'm going to insert some code here before we actually start the vending machine. All right, so I've added some code here to use the operation flavorops.allFlavors and to put those flavors into something called shallow copy situation. And then I'm going to write out all the possible flavors, and then I've got a separator here so we can remember that this is code that I've added right at the beginning. And let's go ahead and run the code. And we see that it writes out the flavors, regular, orange, lemon, and then there's my separator. Now going back to the code, we'll clear out the flavors in the shallow copy situation list of flavors. Let's see how that affects the code. As you can see, I've now not only wiped out shallow copy situation list, but also flavorops.allFlavors. And this is because I made a shallow copy. And let's look at a picture of that. So in our flavorops scope, we have a property called all flavors, and it returns a field called underscore all flavors that points to my list of flavors. Since it returns that field, what it means is it returns this arrow here, and that arrow, or that reference, is copied into the shallow copy situation reference variable in the main scope. So in other words, they point to the same thing. So if you make a change to the shallow copy situation object, you are changing the same storage that all flavors points to. Now, there's nothing necessarily wrong about using shallow copy. It depends upon your situation. But if you needed a deep copy, if you needed to avoid the possibility that data in one region of scope was corrupted by another region of scope, we could do a deep copy. And here's an example of what that code might look like. So what this does is it makes a copy of all those values and puts them in a list, which of course is what we're returning here, a list of flavors. So that if I rerun the code at this point, we can see that regular, orange, and lemon are still there because I've made a deep copy. In other words, there's a separate copy of the data in two different scopes. So if you change one, you don't change the other. So your situation will dictate which one of those things you might want to use. Once we've made that change, by the way, we no longer need the private field that we created before. And in fact, we don't even need the static constructor. The drawback, of course, is that now every time we ask for the all flavors property, we're going to be re-executing some code. So depending upon how many times all flavors is called, that might get to be expensive. you might want to actually go back to the shallow copy. So neither of these is necessarily wrong. It's a matter of what situation fits your needs the best. All right, the next exercise is to change the CANRAC implementation to dictionary. So looking at CANRAC here, we now see that we have a field that's a dictionary. You do need to create the dictionary object. So we're doing that in the constructor. That could have, by the way, been done in the declaration of the field. In other words, it could have been done up here. It's really a matter of personal preference. In any case, you do need to create the dictionary object. And once you've done that, you can index the dictionary object directly using flavor and numerals. Much less conversion is necessary. In this case, of course, we're still using the string version of add a can of, so we do need to make that one conversion, but everything else is cleaner. Exercise 5.3 is to create a coin box. This gives us an opportunity to use the list collection. And as described in the lab introduction, we have a number of properties, and we ask that those properties be implemented using LINQ. So here's Coinbox, and we've created a private field that is a list of coins to hold the coins. And then when we construct the Coinbox, we're creating a list of coins object. Notice that this is also a shallow copy, which, by the way, is all I asked you to do. So if you did a shallow copy in your code, that's perfectly fine. So as I said, this is a shallow copy. In other words, we're simply copying whatever is passed in as seed money into box. That means that there are two regions of scope that share that space. That may or may not, again, be what you want. Let's consider what some code might look like that did a deep copy instead. So now this example shows us how we might create a copy of the list of coins parameter called seed money and assign that copy into box. And for withdrawal, here's an example of using a LINQ query. So we'll get all the coins from the box. Each one will be called first coin. And if that first coin is equal to the coin denomination, whatever was passed in here, then we select that coin. So all I really am trying to do is get the first coin of a given denomination. So if the count is greater than 0, I'm going to go ahead and remove the first coin. And you'll notice that both count and first are extension methods. Here's $half count, again implemented as a property using LINQ syntax. So what we're trying to do is capture all of the coins in the box that are equal to $half, and then use the extension method count to tell us how many of those there are. And the other coins are done in a similar fashion. Optionally, you might have wanted to parameterize those LINQ queries a little bit, because there is a fair amount of code duplication there. So that would look like this. We create a private method that takes as a parameter a coin denomination, and it contains that same LINQ query, except now we're using the denomination in numeral parameter. And that means then that $half count is reduced down to a call to that private method plus the parameter $half. Now I'd also like to show you how you might override the toString method for this class so that it would be a little bit easier to write out a coin value. This was not actually called for in the exercise, but it might be useful. So what I'm going to do is I'm going to type override, because this is actually an override, and allow Visual Studio to give me a stub of this routine. And now I'll enter the code for it. So that's one possible definition of the override for the toString method for coin count. The next exercise is 5.4, exceptions. So here we see this in the flavor file. So this is part of the toFlavor method. And if a string is passed in that does not belong to the enumeration, then what we're going to do is go down to the else part and simply throw invalid enum argument exception with this as a message. And then we want to catch that in our main. And here we see an example of that try block. We read the string in. We attempt to convert it. If it converts, great, our flavor is chosen. We can continue on. But if it does not convert, then we will drop down to our catch block. And in this case, catching invalid argument exception and writing out the appropriate message. And that will allow us to go back to the top of the loop and attempt the whole thing again. Optionally, you might have created your own exception called VinBadFlavor, and that would look like the following. As we see here, we derive from exception. We have three constructors, one that takes no parameters, one that takes a message, and one that takes an inner exception. And then optionally, we've created a fourth one as well for a little more flexibility. And we don't actually need to do anything special in the body of these constructors. All we're doing is constructing the exception object itself. To instantiate that, it looks like this. So in the else part of your toFlavor method, you simply throw a new VinBadFlavor exception instead of the system-defined exception. And that's the review of assignment 5.